All right, I'm going to go through the examples of graphing a system of linear inequalities. And so the directions say, oops, hey, at least it's not red this time. Directions are going to say graph each pair of inequalities and indicate the solution with shading. Okay, so we're going to start off with a pretty easy example. Let's do x is less than or equal to 2 and y is greater than negative 3. All right, so with x, just having one variable, I know that x is going to represent a vertical line at x equals 2. And then I look at the inequality of less than or equal to, and it tells me my line will be solid. And remember, with vertical lines, I can't shade above or below, so I have to shade right or left, and less than is left. On the other one, when I have just a y by itself, that means I'm going to get a horizontal line. And this one will be at where y is equal to negative 3. Now this inequality is, tell me I'm going to get a dashed line. And the I'm going to be shading above with greater than. So I'm going to go ahead and graph this. And I'm going to kind of gear my graph to the numbers I have. So here's my x-axis, y-axis. I always label that. I make tick marks on my graph. I label at least every other point. Okay. And then I find where x is 2, and then I draw a vertical line through it. And I'm going to show you a variety of ways. You kind of have to pick the way that works best for you on how you want to do this for your homework. So I'm going to hold off on shading for right now. On the next one, I'm going to go to where y equals negative 3, and I'm going to dash a line. And I'm going to shade above. So now what I want to do is try to figure out where I have the overlap of blue shading and green shading. And if you notice, it's going to be in this upper left-hand corner. Now, my favorite number, my favorite ordered pair is there. That's 0, 0. So I'm going to test them out. Now, I have to test them in both equations, and it needs to be true for both equations. So I substitute in 0 for x and ask, does 0, is it less than or equal to 2? That's true. So that means 0, 0 is a solution for that inequality. I plug in 0 for y, and is 0 greater than negative 3? That's also true. So what that says is you need to make sure that you're going to shade where 0, 0 is. So the solution to this system is the boundary lines starting from, and I'm going to put a little dot at that point, this point right there, up on the blue, left on the dashed green, and that area shaded. Okay, next problem. A little bit harder. We're going to have y is greater than or equal to x plus 2, and y is less than 3 minus 2x. So on the left equation, it's already in slope-intercept form, so I identify my key pieces. The y-intercept is 2. The slope is in front of the x, which is 1, and I'm going to write it as a fraction, so I'll give it a denominator of 1. And the greater than or equal to tells me I'm going to have a solid line, and I'm going to shade above for greater. Now I do have an issue with the second equation. It's not exactly in slope-intercept form, so I need to rearrange the two terms. And I get negative 2x plus 3 Now I'm ready to identify the key pieces. So my y-intercept is 3. My slope is -2, which I write as a fraction as -2/1. My inequality less than tells me my line is dashed. And it tells me to shade below. So I'm going to gear up here and see where I need to do my... We have only positives. Oops. On my y's. So we're going to go 1, 2, 3, 4. Label every other one. 1, 2. And then let's go ahead and graph. So the blue guy, I'm going to go to where b is 2. And then I'm going to rise 1 and to the right 1. So that's going to take me to the point 1, 3. I'm going to get a solid line through those 2 points. Now I'm going to do things a little differently than I did last time. This one I'm going to go ahead and I'm going to shade above. Okay. The second equation with green, I'm going to go to where b is 3, the y-intercept. I'm going to rise down 2 and to the right 1, so that takes me to the point 1, 1. And then I'm going to write a dashed line through those 2 points. And I'm going to shade below. So notice here I've got 4 sections. I've got a completely blank section on the right side. At the top I have just a blue section. On the bottom I have just a green section. But on the left side I've got a blue and green section. And that's what I'm looking for. I'm looking for that doubly shaded region. So what I'm going to do is test a point and make sure that I have a good point. So I'm going to pick, let's do -2, 2. And I'm going to test them back into my original equation. So y is 2 when x is -2. Oops, I don't need that, sorry. And is 2 greater than -2 plus 2 is 0? Is 2 greater than or equal to 0? Yes, that's true. And then we'll try the next guy. Y is 2 when x is -2. So 2 is less than 3 plus 4. 2 is less than 7. Yep, that's true too. So what that tells me is I found the great shaded region. So what you're going to need to do if you decide to shade both of them fully is you're going to have to highlight for me what the actual answer is. So one of the things you could actually physically do is bring in a highlighter. And you could highlight the lines and then highlight the area. So then that tells me this is the part I want you to look at and grade. Okay, so that's an option as well. All right, and then we have one more to do, and he's going to require the most amount of work because the equations are not going to be written in slope-intercept form, so we're going to have to get them into that. So the first one is 2x plus 3y is greater than 0. The second one is 3x minus 5y is less than or equal to 10. So in both cases, we're going to solve for y. So it gives me 3y is greater than -2x, divide by 3, and we have y is greater than -2/3 x. So I'm going to go ahead and identify all my key pieces. There is no y-intercept, so he's going to start at 0, which will be the origin of my coordinate system. My slope is -2/3, and we've talked about the importance of putting the negative in the numerator. That way I'll always run right, but I'll either rise up if it's positive or rise down if it's the top number is negative. And then let's see, we've got a greater than symbol, which means dashed and shade above. Okay, second equation, again, we're going to start by subtracting 3x from both sides, and we get -5y is less than or equal to -3x plus 10. Then I'm going to divide by -5, and I need to remember when I divide by a negative, I need to also deal with changing the inequality symbol. So that gives me a y changes to greater than or equal to. Two negatives make a positive, so I get 3/5 x. Signs are different, so I'm going to get a negative, and 5 goes into 10 twice. So my key pieces of information is my line crosses the y-axis at -2. His slope is 3/5. Greater than or equal to is solid, and above. Now this is strange. This is the first time we've had both inequalities facing the same direction, so this will be interesting how the graph looks for this one. So let's see, we need negative, positive, so we're going to do this. Lots of x's. And again, your graphs are going to look so much better than mine because you're going to be using graph paper. And you'll have everything spread out evenly. So we go to where y is 0, which is right here at the origin. We're going to rise down 2 and to the left 3. So that'll take us to the point 3, -2. We're going to get a dashed line. And again, this one I'm going to shade above. For the second equation, I'm going to make a mark at where y is -2. I'm going to rise up 3 and to the right 5. So that's going to take me to the point 5, 1. Now that's going to be a solid line, and I'm also going to shade above. So what I'm going to do is test a point that I think is in the doubly shaded region, and I'm going to pick an easy point. I'm going to pick 2, 0. I like to pick a coordinate that has 0 in it. You have lots of choices. You could have picked 0, 1, but I just chose this one. So 2 times 2 plus 3 times 0 greater than 0. So I get 4 is greater than 0. That's true. And then let's see, 3 times 2 minus 5 times 0 is less than or equal to 10. And I get 6 is less than or equal to 10. That's also true. So what I'm going to do is use a whole new color, and I'm going to just outline my solution in this whole new color. So it's this part of this boundary line. It's this part of this boundary line. And it's all of this doubly shaded area. So that's a third way of doing this. All right, enjoy.